the oh, okay. Oh, so the opcodes for F integer load, F store, it's either either you load a float and store an int, or load an int and store a float. So those are the two conversions. So I'm a little confused. I thought we maybe that's marking. Okay, we're getting. Well, let's move right along. I got to finish. So we convert, if it's not a float, we convert to float. And why are we doing this? Oh, this is to for floating point operations. They have to go to memory, so we make a little chunk of memory. Let's do an example just to show what we're talking about. Okay, so F64 F plus equals 1.0 is 399. That's just a little tip. So O trace on what? Oops, F64. Okay, we didn't get a warning. So we start like that, and we don't put. I don't think we don't put floats in register variables. We don't put floats in local variable registers. Okay, so it converted. It starts out RISC and then it makes CISC, and the CISC operation is add equal. It started out broken down. No, it didn't start out broken down. Anyway, so we do an add equal, and here's one argument. This is the address, not address, not address. What? Of course it's. What do you mean it's not address? We don't do floats in registers. What? I could swear. Maybe it gets overridden if it's float. Okay, so we're telling it to store the result of the add equal, to fetch and store F8 off base pointer, and the value is an immediate. I said 399. What I meant was 3FF. This is 1.0. So let's see how it coded it. F load 1 onto the floating point stack. F add F8 off base pointer, and then F store. So it coded it pretty well, didn't it? Okay, so now let's see if you're curious, what if we say 1.0? I don't know if it's smart enough to do that. No, oh, it is smart enough. Converted it. Okay. Let's add I. Now we have we're adding register RAX, and we have a convert argument 2 to double. That's I should call that float, I guess. I tried to get rid of the old terminology, but it's pretty difficult. That I can change. Anyway, so we have now we have an FILD because it's an integer load. Then we add, we create a spot on the stack. Then we add the register variable. We have two register variables now. I'm sorry, local variables. And then we store. I don't know why we created that spot on the stack. Oh no, we're removing it. That was where we got the we pushed the integer, so it didn't really do us much good having a register variable. That's kind of ironic. If we had not made it register, it might have been better. Anyway, so it was register. We had to convert it to a memory for a float operation. Then we had to get rid of the memory. And of course, base pointer stays steady. We worked off the stack pointer. Okay, so that's what's going on. So A1 first. So I'm highlighting the spots where code is made. So this is if it's not equal to F64 and it's a stack. Oh, that almost never happens. That's a nightmare. So we changed the subtract and divide to the reverse. I don't know why we didn't start with the reverse. Why we bother with this silliness, unless it's coming from somewhere else. Now the way I handle my operations is I bunch together all we have 64 bits for available for we have 64 bits available for we have an argument, which is the operator type, and what the heck, there's no reason not to I go crazy. So we pass an argument to that function, and I go crazy with all these 64 bits available. So I code the when you have something like a floating point add, there's the /op. That's the part of the opcode for the normal operation, and these others are usually there's two different instructions you have to deal with. I don't know what these two are. I'm just giving you a heads up that those there's a lot of individual numbers. What I'm talking about is we break these things up into pieces and use different parts depending on what we're doing. So for example, let's just go look at that op whole label. So there's the operator, we're passing it in, and if the bottom byte, then we change the bottom, we change not just the bottom byte but the whole thing. Then we're handing it all, the complete thing to /op. I guess that can tear it apart. Bottom byte, bottom byte, bottom byte, /op. Okay, so /op. /op's in here, isn't it? Now this has the operator type. This is for, oops. So if let's see, it's checking for I don't know what that is. One of the operators is special. We do a modder with the low byte. Check. Now when we're doing the /op, we use the next to lowest byte as part of the instruction, and or when it's a different size, when it's 16-bit versus 8-bit. Now this I don't think this would be relevant in a float. operation, or if it's Rex, if it's 64-bit. So I have the 1632 and 64-bit. No, there is. Anyway, so that's what that is. Let's just call it good enough.